Okay, the topic for today is not really tech hands-on lab, but you can sit back and listen. This is easygoing. So we start with some of the framework, application development framework. Um, so to not only the way that you conduct your semester project, of course, when you do your semester projects, you can follow this. So, but in general, not simply your small project, but if it is bigger enough, multiple developers should be involved, then this framework needs to be followed very carefully. The first step that you have to consider is to define objectives. So you need to define the purpose of your mobile applications very, very clearly. So it identifies the target audience and also determine what problem and what you want to achieve. Okay. So once objective is defined, then you have to select the platform that you want to run your targets. Usually it could be iOS and Android, both together. But on your development phase, you may try on one specific platform. Therefore, if your application successfully functioning on one platform, then you can migrate that application frame to other platforms. Okay. In that case, you have to consider demographics. Your audience will maybe a one specific country or all over the world, and also the age-wise, are you going to make it for kids or adults or seniors? So all those factors needs to be selected. You may select all of the wide variety of demographics and all possible platforms. That is fine, right? For your markets, if you want to raise the revenue of your companies that build and distribute mobile applications, then yeah, you need to wide the markets. And then sketch the wireframe. For example, when you sketch your architecture of the application, not only the way that you can see, we call that view. View is simply the view that you can see on your the mobile applications that you have used so far, right? So on what would be the first view on a given the application, and when it asks you to respond for user interactive mode, then once you enter your input and click button, then it moves to other view, right? So there may be a sequence of views. So all those things needs to be sketched out. May not be in a concrete way, but by sketching the view, sequence of views, then you may understand it, the layout of your applications. So that's help, right? So at this moment, I would like you to, for your small project, semester project, I want you to sketch the layout of your applications. So it should explain the layout and flow of the applications. All right. So simply, it would be very simple. Let's say if you have this, the first main view, then you can say main, and then maybe some of the button here and there. So if it is clicked, then it goes to another view in a tree structure. If there is another depth, then it goes to another, right? Here it may be a dead end or some other path, a sequence of that view. Maybe at some points go another and another button there, so it may come back. So various different kinds of the sketch is possible, okay? So this is simple visualizations of your the application flow and layout. So layout one view, then you need to lay out what you want to place each of these. And then in this way, it explains the flow of those. Here it may be a dead end. That is also possible, right? Or it may come back all the way to the main view. All such, the data flow or the flow of views needs to be explained. That is a sketch or fire framing. So I want you to do this. This will be another homework assignments, right? This is simple homework assignments. Next homework assignments. Okay, so the fourth step is the design and UI and UX, user interface. Design and user interface. Design user interface, that is a code. Depending on the packages that you rely on, different coding schemes needed. So maybe in a couple of weeks, we'll look at iPhone apps UI design. This class does not use any extended macro level of the third-party applications. We're going to look at simply the generic, so-called native, the tools that are provided from Apple, okay? And after that, we need to do back-end developments. Usually this back-end development for this one, excuse me, our the hands-on lab, I developed this and I wanted to focus on that, right? If you want to work on this back-end developments, then there's another course for computer science majors that is a distributed application developments, right? I believe something like that, right? I'm teaching that also. There you can work on that back-end development. On back-end of your mobile applications, basically there should be a database running and some of the middleware, multiple the middlewares that you have to develop. Therefore, whichever the information needed, different kinds of the middleware is serving your requests from your mobile apps. And then front-end developments, this is something that how you can visualize it. So we do Swift and Swift UI on iOS for our case. Maybe some other classes, it may use Java or Kotlin for Android apps developments. But we're working on the Apple apps developments, okay, iOS apps. And API integrations, third-party API may be needed when you develop your apps. For example, if you want to develop train schedules, although there is a train apps available, but if you want to simulate a little bit of those, not the complete fashion, but you want to exercise a little bit of those, then of course there is a API servers available, right? So-called the RESTful server, like our cloud server that I developed, where there is a middleware running. Similarly like that, there are lots of API providers available. So you can hook into that server, get some answer from there. Some of the API servers charge the services, particularly if it is data from, for example, Wall Street. Then depending upon data ticking, how fast, how quickly that you can receive data from Wall Street stock trading, there are different pricings, right? If that is, for example, 1 minute delay, then usually many cases they do not charge. But API, the usage of API is so restricted, limited, and also restricted. Therefore, it's not easy to use. You may try, right? You can get some data from Wall Street trading data, or you can get some data from, if Mercy class registrations, the system provides API, then you can use it, but probably it is not, right? Building API, that is another extra work. So they don't really do that. There are all kinds of those API services available. Another one is, for example, airplane schedules, or movie schedule from the movie theaters. Longer time ago, maybe 10 years ago, when I first started to teach this course, then most of API servers are free of charge. But now they start to charge. But you can find something if they are some way generous, right? Some small companies, if their goal is to raise their revenue from selling APIs, then they usually charge. So, but you can find out some free of charge API services. Testing, once you have that, you have to test it and develop. Deploy. The way that you can deploy depends on the platform. For Apple, there's a app stores. Google, there's a Play Store. And also, if that is your program, then you can deploy immediately onto your iPhones. But that is not public deployments. Okay, so up to this 9 steps, then now your application development is done, and someone is subscribing your applications. And then next one is the maintenance. You have to maintain your programs. If there is updates needed, then you have to do. And marketing, that is to raise your revenue. User acquisitions, that is also, you need to get some feedback from users to enhance your applications. And at the side way, then you can do analytics and iterations. So you need to analyze how your customer likes your applications, and what is there any competitors? Always there are competitors. Then you have to provide anyway some of the benefit to the customers, right? By enhancement. So there is a frameworks in general. So let's start with the Android apps development platforms. So Android app provides you Android Studio. Like in our case, we use Xcode, but Android has Android Studios. About 10 years ago or longer, Android does not have studios, so we use, I think at that time, some of the studios. I think it's called the Eclipse Studios at that time we used. But now, a little bit handier. Okay, and then programming languages. Originally, there's written in Java. So Java is the best way that you can use for Android apps developments. But there's another handy micro level of the language developed, Kotlin. If you want to develop fast applications on Android, then you can use Kotlin. iPhone has the same things, but there's always pros and cons in between native languages or anything in macro levels. Macro levels benefit from that is you can build it fast, but it has drawbacks, right? It doesn't provide you all everything in details. If it doesn't work, it doesn't work. So you have to come back to the Java level. Same thing, we do Swift, but there's another similar things available. And then Android SDK, software development kit is needed. There are some of the graphical user interface, some libraries available so they can use. Some app bundles also available for Android apps. Communicating between views. When it comes to Android apps, then they usually put all the data on the bundle, and then that bundle needs to be passed to other views. That is the mechanism for Android. And Google Play service, that's for Android. Likewise, iPhone apps, we have Xcode and then Swift language. Objective-C, that is the rock bottom foundation of the Swift. So usually the language that we are using for iPhone apps developments, Swift, usually 99% Swift. But when it comes to some specific items that may not be migrated to Swift, then still we have to stay on the Objective-C's, okay? But not often. iOS SDK, that is available as well. Interface builder. Some of the drag and drop interface, that is possible, but we're not going to do this. Until last semester, my class, I asked them to use a drag and drop interface, which is called UIKit. UIKit. So we use UIKit for UI developments. Now in this semester, from this semester, we are going to use Swift UI. Swift UI is more coding style. UIKit is like a drag and drop. So we have to lay out the views. Meanwhile, we have to do some of the coding behind it. So UI layout and coding go together. That is for UIKit. Swift UI, why should we do this? Two things. Always one page for view, another page for codings. Why don't we do only one codings? There's a Swift UI. Once you know the Swift UI, much simpler, okay? And coding itself, software itself, manage everything. But if you stick to UIKit, drag and drop interface, then some of the layouts, because it is not really formally coded by the language, but because of drag and drop fashion, it may not stick to the position as you place. It's not really fully under your control, under the developer's control. That is a weakness of UIKit. All right. So Swift UI, once you know, this is a lot better. That is the solutions. App Store Connect. App Store Connect is an Apple platform for managing and distributing iOS apps on the App Store. Once you developed, and if you think, oh, I want to sell my developments, my iPhone apps, then you can connect to app stores. It allows developers to submit their apps for review, manage app metadata, track app performance and analytics, and handle in-app purchases and subscriptions. And Apple developer programs to distribute your iOS app on the App Store, you will need to enroll in the app developer program. I am enrolled in there. I subscribe it. I have to pay the memberships. It's not, it's quite expensive. But anyway, you can do that. Okay. So in any way, anyhow, if you follow, yeah, of course you have to follow the framework that we covered, and then depending upon the platform that you choose, iPhone or Android. Once it is developed, then testing. Okay. There are actually manual testing, automated testing, and therefore you can get the user feedback. This is very important, right? Once you develop your apps, and if you want to sell, if you want to maximize your marketings, then testing is important. Basically, two types of testing. So unit testing, some of the units. So there's a tools available. For example, in Xcode, there is a XC test. And then functional testings, in general, how it performs, that you need to test it. And performance testing, how fast that your program runs. Apps, some apps. By the way, recently when I access my account at Chase Bank, the performance of Chase Bank login service is degraded. Usually they have two-factor authentications, so that ask you to enter some of the code that they text you, but they don't text me. They text me only when I click, after I wait, maybe 2-3 minutes, and I realize that, oh, this may not be appropriate right now. So I click, there is another option, say another methods. So click on another method, immediately I receive the code. I don't know what that means, because I already clicked that. If I receive the code, that code is not anymore useful. That happens. Lasts a couple of days. The performance is so bad. I do not know what happened to Chase Bank. For that, they need to have some of the automatic testing tools and get some feedback from user. So they have some of the reactions, some proper treatment needed. Compatibility testings ensure that your web works well on different platform models. Compatible. Some iOS, some client has older versions, some client has new versions, different screen size, and also different speed of the network. It should be compatible, right? As technically, it is not really, they are all identical in performance and functionalities, somehow close to each other. And usability testing and localization, internationalization testing, of course, they are all needed, right? And then beta testing. But what is beta testing, by the way? Before they make a formal announcement of their products, if they have a small group of their clients, then ask them to use. So before make it public, they want to get some feedback from their loyal client. Okay. Usually that is the case. So beta testing. Beta testing is very useful tools before they make a formal announcement. Crash and error reporting. Some apps while you're using maybe crashed, right? You may realize that when you develop, even if your apps is very small in size and small in performance, the functionalities, but when you use your app on your device, they be crashed from time to time, right? So integrate crash reporting and error monitoring tools such as Firebase, Crashlytics, and Apple App Store Connect crash reporting. So somehow you need to get some report when it comes to crash. And accessibility testing. The issue of accessibility is quite common these days, and in most cases, it is required. Even when I create the course syllabus, then university requires statements, the proper statements written in that syllabus about accessibility. So you may see that, right? Accessibility is for the handicaps, disabilities, somebody who are not normal. So how can they do? Test with assistive technologies like voiceover, dynamic type, switch control. VoiceOver is a good tool, right? Most the mailer systems, you can email by speaking. And also the ChatGPT, for example, then it understands your spoken language, right? Very easily. So VoiceOver is some of the services for accessibility. Okay, next point is security. That is really, really important, right? Security. Assess the security of your app by conducting security testing. Verify the sensitive data is properly encrypted and user authentication is secure. Our first hands-on app for iPhone apps development is the authentication, login process. Actually, there are 3 kinds of login process that each of those that we want to implement. First one is your login name and password that may be hard-coded on your coding list, which is not really recommended, but anyway, that is possible, right? We can do that very easily. And then second paradigm is that you can save your login name and password in a database. Remember that each microcontroller, like our iPhone, has a database running, right? in a background, although you don't use, although you don't know, it is given by default. Usually it is called the SQLite. It's a light version of SQL that runs. It's not MySQL, but similar to that. We'll look at that, okay? So we can save login and password there. Then your app authentication is made based on local database. Third option is to use a remote database. Okay, so that remote database is given by our cloud server. So login name and password comes from your cloud server, from remote databases. So all three distinctive paradigms will be discussed and implemented. Techniques involved there. It is simply authentication, but techniques that you want to use for your small the semester project. Most of the techniques involved. So that is a good way that we can the practice for our hands-on. Okay, not only security testing, but our coding testing. All right, so that's a testing, how we can test. Next one is maintenance and updates. There is no single system. System means digital systems. No single systems perfect. Even Microsoft Windows. What is the history of Microsoft Windows? Maybe several decades. Who developed? How many people developed it? I think so far millions of people, the programmers developed the Microsoft. Is it now perfect? Never, right? So always maintenance and upgrades needed. Same thing, your application, your iPhone apps needs to be updated, needs to be maintained. Number one issue is a bug. If there is a bug, then you have to debug it, right? Usually bug. One way that you can avoid the bug is to use exception handling, right? Probably you tried. Exception handling is common in most languages. Some of the exceptions that may be predefined, some of the exceptions not defined by your program provider, your language, programming language provider. For example, if it is a Java, then Oracle Teams improves Java functionalities so that they create and more exceptions, and also how to handle those exceptions. If they are already developed, then we simply catch that exception and then use it, right? If it is not defined, of course, many of the exceptions not defined, because developers are developing something that is very common, that is for all purposes, So if your app is so specific, likely almost unique, therefore it can raise the revenue very quickly, then exceptions are not known before, right? So you have to develop. Once you develop exceptions well, most of the exceptions that you developed, then your system may not crash often, right? Somehow you catch the exceptions on your codings. So in cybersecurity undergraduate program, I am also teaching how can we develop softwares in secure way. There is a security issues, another security issues. How can we avoid system crash? Okay, bug fixes. Continually monitor user feedback, crash reports, error logs. Then we have to cope with it. We have to fix it. That is simply manual fixations, right? But at the development phase, you can handle such errors because you cannot cover all possible cases in your codings, right? You touch some of significant behaviors, but the rest needs to be considered also. That is the exception handlings. Okay, number 2, performance enhancement. Maintenance is needed to enhance the performance, right? I realized that because I purchased my iPhone device in January. That was not planned. But during winter break, I was under the sea. Not really a long time, but I tried to snorkeling, for example. But I forgot to leave my phone out. So under the sea, I enjoyed, and all of a sudden, oh, my phone is here. So my phone was on my the pockets. You know what? If it is under the sea,
I mean, how deep were you? That's the thing.
Doesn't matter.
Have some water.
Doesn't matter. It's a salt water, right?
Oh.
The sea, there's a salt water.
Mm-hmm.
I didn't know how to. I've never thought, but if you drop your phone on the sea, then you can leave it and dry, right? You keep dry. Do not turn on the power until you make sure your phone dried up. But under the sea, what happens? Leave it to dry until it is completely dried. What is the first thing that you have to do? You have to drop it in clean water and then dissolve that saltiness long enough. So maybe if it is under the sea water, then you have to put it in the clean water for maybe several hours, and then make sure it is cleaned in the regular water. After that, you have to dry it. Then it works. But I didn't know that. So all the circuits are short,
lost all. So I purchased the new ones. My old iPhone was iPhone X, which is the version 10. The current version is 16. So I realized the difference between iPhone X and iPhone 16. iPhone 16's the performance and everything should be improved, upgraded tremendously if we compare that to the version 10, right? That is true. But when I feel it, is it really the truth? When I feel? It's not really. Why? So I fight.
I'm sorry I'm late.
That's okay. You are.
Yeah.
How's your traffic? Bad traffics?
Yeah.
Yeah, always. That's fine. I had the bad traffics, but I left home early. Therefore,
Yeah, there's sometimes like the subway stop immediately on the road.
okay. So do not plan it in the right time. You have to make some cushions. Oh, I wanna be there 1 hour earlier. Then,
Yeah.
then okay. Right, Malix? So he made it this morning. Okay, so what happened is that the current iPhones runs so much things, so a lot more things than the case of iPhone 10. iPhone 10, it runs a small amount of programs. Although I don't use, it runs small programs. iPhone 16s, I think maybe 10 times more programs running. Foreground, background, it checks something. So much things needs to be monitored and checked by itself. Okay? Therefore, when I see the performance, I don't use all of those, right? I use only one app at a time. So when I use one app, performance is not as good as before. Some cases. Why? Because a lot of resources doing something else in the new phones. So best thing that you have to do is when you purchase the new phones, you have to disable so many things. Then it'll be definitely better. But if you enable all the capabilities developed in new versions, then the way that you feel the performance is not really significantly upgraded. Okay? So this maintenance enhancement, we always improve, always try to enhance the performance. But for client experience, it's not really goes to client experience, client's satisfactions. So yes, you improved it, but you have to tell them we improved this, but you have the options to use or not to use. If you use it overall may not be greatly improved because so much things are working behind. Question.
I think it's also like what they allow you to customize, right? Because with the new iPhones, the camera, they do like post processing every time you take a picture.
Right.
You can't disable that. It's just built in.
Right.
And the other thing is, I think they do it too, where they do only a little bit improvement with every model, so they can keep selling more iPhones.
Right.
You know.
Thing is this: when you have some experience, when you do code, 80% of your time, so your project works. The last 20%, in order to achieve, for example, in order to improve from 80% to 90%, then you have to put maybe same amount of effort and time that you achieved the first 80%. In order to achieve 10 more percent, let's say 80% to use the 10 hours. To improve next to 10%, then you have to spend the 10 hours again. Next to 5% improvement, you have to spend another 10 hours. So getting to closer to 100, customers don't feel it much, but your effort you spent really massive, great amount. I think you have some that experience when you involve some of the projects. Yeah, first 80% you can achieve quick. Next to 5%, there's a really headache. You may not achieve. Then you need to get some help from some of. You need to include more teams. Okay. Compatibility upgrade, that is always needed, right? Security updates. For this security updates, that is really big issue. Because there are lots of attackers, right? Some countries, they have professional attack teams, right? They try to attack all over the world. And the rest of the world try to defend. We call that virus, right?
Did you hear about the latest crypto exchange hack from North Korea?
Is that right?
Yeah, biggest one so
How
far.
come they have that high tech?
1.4 billion. They fooled the people, not the. And it's crazy how like they even know what they knew to do to like do the social engineering. But yeah, biggest hack so far in history.
When did it happen?
It's like a week ago.
Week ago.
Yeah. Insane.
Probably that's not developed by themselves. Maybe steal it from somewhere. Technology itself. All right. So more maintenance. Not only bug, debug, performance maintenance, compatibility updates, security updates. So we still have more. Future enhancement. Some of the new features may be available. User interface, user experience, UI and UX, that's also needs to be upgraded. Localization and internationalizations. And App Store optimizations. So regular review and optimize your App Store listing, update app screenshots, descriptions, keyword, promotional assets to improve discoverability and the conversion rates on your App Store. Keep an eye on changing trends and adjust your ASO, App Store optimization strategies. This is for, in your case, for this class work, we may not do any of those, right? We are not at that phase, maintenance phase. Maybe testing, yeah, you have to, as you develop, you test a lot. So only up to testing. So maintenance and updates, that is extra that you have to consider. So more maintenance, push notification. There's always two fashions available between server and client. push or pull for smartphone apps. Servers usually push some of the maintenance and upgrade, right? Rather than your client wants to see, hey, I want to see if there is any upgrade version available for my phones. But usually developer push the notifications, right? So platforms are usually pushed by the developer. And is the components of your apps, there's a pool service required. For example, if your smartphone application where there is a button so that you can click that button saying request. In response to that button, your app pull the data from the server. Your client, your smartphone needs to pull the data from the server. So two modes are always coexist, push and pull. Analytics and performance monitoring, that is needed for further maintenance and further enhancement. User support and feedback. Most of the smartphone applications that you subscribe, there's no place that you can say, hey, I want to give you feedback. They don't do that, right? If it is not the case, then what should we do for user feedback? You can build that components on your smartphone apps. So if there is any malfunctionings without or with the notification to the users, the clients, you simply knows your inside of your applications, you can go back to your developers. You can make it, right? Like a backdoor. If that backdoor is usually dangerous for security purpose, usually prohibited. Along that backdoor, developer may be able to control continually. Why, as far as the client uses that apps. So the App Store, when they verify your applications, first thing they try to find out is to see if there is any backdoor open for the developer. Then developer may control your apps remotely. So that is very, very dangerous. But anyway, that is one possible way that you can get the feedback from user continually. You can gather user behaviors silently and send it to the developer. Because there is no formal way that a developer receives user feedback. I don't see any app that I have has that options. So while I'm using my apps, there is another button say, what do you think about my app? So that I can say, hey, your app is something. Do you guys see any such the smartphone apps that you subscribe? Usually not, right?
No, they lead you to the App Store, legal review.
There's another way that
Most
not directly from your applications, but maybe web applications, not mobile applications. There are another channel that you can say. Compliance and legal updates. This is the most important, the compliance, right? Because all the countries, they set up some regulations. In America, for example, FCC, Federal Communication, I think Commission. That's FCC, Federal Communications Commission. They defined lots of regulations. They also, not only our smartphones, but they also do some of the medias, legacy medias, new medias, everything. So your applications, if you use something not in normal, then you have to find out if there is any, if your phone, your developments is complied with the federal or local regulations, laws. Yeah. So ensure your app complies with the latest regulations and standard to protect user data and maintain trust. This is very, very important to user data, right? User data needs to be destroyed regularly. If not destroyed, what happens? For example, the American government is worrying about TikTok. TikToks are very popular to younger generations. Why that is important? Why the government is worrying about TikTok?
It's influencing the votes.
What happens? There's only because if TikTok piles up the user data, let's say the guys at the 5th grade in elementary schools, he made some of the TikTok contents, and he grew up, and that person may become later, who knows, maybe pilot in aircrafts. But when he was 5 years old, then he put there, hey, my life goal is something. But if that is related with aircraft, then that is very strong linkages, right? If that user data destroyed far earlier, then we do not know. But if it is really connected, linked together, and if that information is known by enemies, then that is a big problem, right? That is reasons. So in one of the FCC compliance for the app user information, then when you collect the user data, then you have to comply with it the way that by deleting user data periodically. So you need to make sure that you do not keep user data for example, 20 years. If somebody knows my life for 20 years, for the past 20 years, what happens? Okay, marketing and user acquisitions. Again, App Store optimizations, so-called ASO, optimize the user App Store, present to Can you please close the door? All of a sudden it is. Thank you. In order to marketing, in order to acquire more users, then you need to do this advertisement, right? And influence marketing and public relations. Those are all marketing issues, right? Advertising. Advertising one specific marketing tools. But anyway, there's influencer marketing and public relations. See, for example, YouTube. If you are developing YouTubes, if you are trying to generate and create YouTube videos, the best way that you can increase users, number of users who can subscribe to your YouTube, then among those three ways on the slide, the second one is so effective to increase your users. If you know any influencer, then you can tell them, you can tell your influencer to introduce your YouTube, then all of a sudden you can improve your subscriptions. Likely, decades ago, when you develop web server, no one knows your web server until you put your web server on TV programs. Then if one of the famous TV programs says a www.something.com, this is if you come here, then we'll do something for you. If that advertisement on the TV show, then you can improve your subscriptions, right? So what about the app, your smartphone apps? Some smartphone apps may be available on some of the advertising, right? Paper, newspaper, or TVs. Some apps, I'm not sure this, how effective. Influencer, is there some influencer for your apps? Maybe, possible. Public relations. This is more yeah, some of the press release. Marketing. Not only that, content marketing, app review sites and directories. If there's a customer review, websites available. For example, top 10 list of something. If your app is enlisted in that top 10 list, then you will be, that is one of the best marketings, right? Some of the review sites, you need to try to put your app in that list. Social media marketing and app store features. So more than that, referral, cross promotions. So you can, some of the free applications, they have their own advertising things, right? For example, for recently, the weather applications, the one that I like the most for weather forecasting is AccuWeather. Till recent years, AccuWeather does not show any commercials. Now, lots of commercials. When I see hourly the weather forecast, then they show 2 hours, 3 hours, followed by commercial, and another 2 hours, followed by commercial. So what happens? I want to focus, for example, what is the weather today till midnight? Then I need to scroll, right? Previously, hour by hour, from current time to midnight to nights, there's no commercials. I can see clearly. But now, each every 2 or 3 hours, there are commercials. That's a good way that the website can raise their revenues. And also you can advertise your apps on there. User engagement and retention strategy. Retention strategy is another interesting term, right? Some of the app, if it is free, for example, then you may use it when you need it. Immediately after you complete, you delete it, right? You better delete it. But if there is some way that you can still get some potential benefits, then you can keep it, right? So when you develop your apps, you need to provide your clients more and more, not only one-time satisfaction, but you need to entice them to additional attractions. Analyzing metrics and iteratings. Analyzation is always. Now, finally, analyzing metrics. Download to analyze it. You have to download to measure the number of apps downloads and installed to. And active users, session length and frequencies and retention rates. Those are all something that you need to analyze. Churn rate. How can see yours is better than others? Conversion rates, in-app purchase or revenues, crash reports and stabilities. All the analytics for your the marketings. App Store conversion rate, user feedback ratings, user acquisition channels, funnel analysis, so much of those. So these things, analyzing metrics is a way away from our current situation, right? But when it comes to that, the success in your development life, then you have to consider maintenance and updates, analyze all such things. Okay, this is the end of today's lecture, but before we go, there's some videos that I prepared. Building mobile tech in 2024 and another tech for 2025. What I will do, those are all not really the short, but about 16 minutes, 13 minutes. So we're going to view these recent ones together and the older ones. Anyway, we need to see what it is and then come back to the second ones for entire play, okay? So
Hi, so in this video I'm going to talk about what are the technologies which are available right now through which you can make your mobile app, and which is the best technology to pick in 2024 to make your mobile app business as a success. So currently, if you are an experienced developer or a new developer who is trying to learn mobile app development, in this video, by the end of it, you will know which is the best technology which suits you right now. Either it's a product which your company is building or you are trying to build your own app. So this video will clear out a lot of your doubts, like which technology you should pick. So let me first start with my own experience. So I'm Divyanshu. I have 11 years of experience building mobile apps, web apps, and backend. And I have extensively worked on mobile app ecosystem. I started back in 2012 when the mobile app ecosystem was just bubbling up, and it's been 12 years making mobile app. I have seen this transition from moving from native to cross-platform and the technology which exists right now. When I started back in 2012, like almost 11 years or 12 years ago from now, there were only two ways to develop mobile app. The one was the native way and another was a cross-platform way, but that was not actually very production ready. We used to have like a web app version of a mobile app that was not at all useful, and nowadays like those frameworks have long gone. Some of the frameworks which were available back then was PhoneGap, Cordova, and Xamarin. Xamarin still exists, but I have never seen any production ready or any big company using it. I used to code in Android like with Java programming language, and in iOS you have to use Objective-C. I've always been scared how bad Objective-C can be sometimes. In terms of its syntax, it's a very beautiful language, and I know a couple of expert developers who enjoy writing in Objective case when we were creating apps in Java or in Objective-C. So if you want to create a native iOS app, I would suggest you start with Swift. Well, that's the only option right now. And the new framework for creating UI is not UIKit, it's Swift UI. Swift UI is not a new programming language, it's just a framework which iOS released, which again, Jetpack Compose is again very heavily inspired by that, and they both share similar kind of syntax. So it's a declarative UI syntax in which you write some Swift code and the UI is created. Now, they also provide a preview window. So if you are writing your Swift UIs, you can watch how the UI looks like in real time, which is called like hot reloading. If you come from a web ecosystem, when you change something on your code and the web app refreshes.
okay, this is this much.
So, 10 years ago, if you wanted to build a mobile app, you had two main options. Either native iOS or Android, or hybrid frameworks like Ionic or Cordova, sort of web to mobile converters. And yes, there was also Xamarin and Windows Phone, but I don't see them around anymore. Nowadays, for the same mobile app, you have at least 5 different technologies you can use to build it. And that makes it quite difficult to choose one, either for building the app or for making a career out of it. So in this video, we're going through all the options, looking at the technology behind them, the programming languages, and the tools you can use. This is a necessary step before diving deeper into all these technologies in future videos. So whether you're already a mobile developer or you're an aspiring one still learning, by the end of this video, you'll know exactly what are your options for building a mobile app or for a career in mobile app development. Let's go. If you're new here, my name is Dan. I'm a mobile software engineer with close to 10 years of experience in building mobile apps for startups and for big companies. There's a more detailed video about that. I'll put the link in the description. And for now, let's get back to ways of building mobile apps, starting off with native apps. No, they didn't go away like many people predicted, and I believe they are here to stay. Native refers to the technologies that Apple and Google made available for developers to build apps for iOS and Android respectively. On the iOS side, we have Swift, a powerful and intuitive language introduced by Apple in 2014. But everyone talks about Swift UI. What's that? We'll get to that in a moment. Some of its key features are performance, safety, and an intuitive syntax. But don't take my word for it. See for yourself. Here's a bunch of code in Objective-C and the equivalent in Swift. So I'd say it's no wonder that Swift became the preferred one. On the UI side, for a long time we used UIKit, which is a framework for creating UI with storyboards or XIVs, which are drag and drop interfaces, or directly from code. UIKit uses auto layout and constraints, which allow for a fine control of UI elements and how they are positioned next to each other or on the screen. However, it can take a lot of time to build complex UIs. So now we have Swift UI. Yes, which is a newer, more modern framework for building UIs in native iOS apps. Swift UI has live previews and a declarative approach to building the UI, so overall it reduces the amount of code that's needed for creating especially complex UIs. And yes, that code is still Swift, so Swift UI is not a language on its own, it's just a framework. As for tools, the bare minimum you need is Xcode and the Mac. Yes, that sucks a bit. You cannot build native iOS apps on Windows or Linux. I mean, there is a way, but more about that in a few minutes. Xcode is the IDE for building native iOS apps, and it has tools like a debugger, performance analysis tools, and simulators so you can test your app on multiple devices. By the way, if you ever check the reviews on the App Store for Xcode, you'll see it's a love-hate relationship. Mostly hate. iOS developers love to complain about Xcode, and they have reasons. Additional tools to mention are Cocoa Pods and Swift Package Manager for managing dependencies, and App Store Connect and TestFlight for distributing your apps either to testers or on the App Store. Alright, let's move to Android, where we have Kotlin as the main programming language. Excuse me, sir, what about Java? You can build Android apps in Java? Well, yes, you can, and Java was the first programming language used for Android development, but Kotlin is a more modern language with a shorter and simpler syntax and features like null safety, extensions, and coroutines for asynchronous programming. So please, if you make Android apps, use Kotlin. Yes, I just started my first tutorial. And anyway, it runs on the Java virtual machine and it's fully compatible with Java. So if you need to have both in your project, that's also an option. And as a fun fact, Kotlin is named after an island near St. Petersburg. So it seems like programmers really like naming programming languages after islands. On the UI side, for a long time we had XMLs for building UI components on Android. Each screen or part of a screen was a separate XML file, and you had to write all the components and the constraints between them in that file. And it can get quite messy if the project grows. Nowadays, we have Jetpack Compose, which is a more modern toolkit, and it has a declarative approach, which reduces the overall code, and you write code in Kotlin. This is the best. It's kind of the Swift UI of Android. On the tools side, the go-to IDE is Android Studio, which, similar to Xcode on iOS, it has performance monitoring tools, debuggers, many additional cool features compared to Xcode, and also a built-in emulator, again for testing on different devices. And if you ever used Android Studio, you know it's kind of a Russian roulette game. You never know if they fix bugs or if they add new ones. Additional tools include Gradle for building the app and its modules, and also for managing dependencies, and Firebase App Distribution or the Google Play Console to share your app with either beta testers or on the Google Play Store for everybody. Alright, now that we explored the native options, it's time to move to the world of cross-platform frameworks and apps. We will talk about three major players in this space: React Native, Flutter, and Kotlin Multiplatform. Wait, you said you won't talk about React Native. No, I said maybe later, and now is that later. Unlike on native, where you have separate codebases for each operating system, with cross-platform you can have a shared codebase and deploy your app on Android, on iOS, and sometimes even on web and on desktop, which can increase both the consistency and the efficiency of app development. But how can this be? How does it work? Well, they provide an abstraction layer on top of the platform-specific code, so you have a unified interface to interact with each smartphone's capabilities. This abstraction layer allows developers to write code in JavaScript or in Dart, while still being able to access device-specific features. Of course, they are not a silver bullet solution for everything, and they might come with limitations and trade-off when it comes to performance, stability, and functionalities. So let's give priority to the elders and start with React Native. It was the first such framework that really became popular. Developed by Facebook in 2015, React Native allows us to create mobile apps using JavaScript and the React library. It was the first solution that offered both a native feel and a shared code base. So it's no wonder that it increased so much in popularity. As a fun fact, Facebook said it was created in a hackathon, when they wanted to bring the ease and efficiency of web development to mobile. And as you probably know, JavaScript is one of the most popular programming languages in the world, which means it has a large community and lots of resources to learn from. On the UI side, just like in React, you are using JSX for creating user interfaces. It's an extension for JavaScript that kind of looks like XML. And then React Native bridges this gap between JSX and the native components using a so-called bridge, which means that on iOS it will render native iOS components, and on Android it will render native Android components. This is quite impressive, and it gives you that native feel and user experience that we mentioned before. As for tools, the most popular IDE is Visual Studio Code, and you will also use the React Native command line interface to build and run your projects. Also, probably the best tool we can mention here is Expo, which is actually a set of tools for React Native that simplifies development even more. Expo comes with an additional set of JavaScript APIs that cover the most common features in mobile app development, like push notifications, for example. And you can implement that without writing any native code. You can even build and run your apps on your phone without installing Xcode or Android Studio. Remember what I said earlier about building iOS only on a Mac? Well, Expo is that single other way that you can build for iOS without having a Mac, because it offers a cloud infrastructure for that. So yes, Expo is pretty cool. The only downside is that when you use Expo, you are not allowed to write native iOS or Android code for some specific features. Alright, let's move to Flutter. I don't want to keep you here all day. Flutter is one of the most popular cross-platform frameworks of today. It's developed by Google and it was launched in 2018, so 3 years after React Native. But it quickly caught up in terms of popularity, even though the programming language that you use is Dart. Dart? What language is that? Yeah, that was my reaction too. But actually, Dart is not that bad. With Flutter, you can create apps not only for iOS and Android, but also for web and for desktop, although it's not so often used for web and desktop. And some of the exciting things that it brings are a big set of predefined components, very good performance, and a highly customizable UI. Flutter uses Dart, an object-oriented programming language, and in terms of the syntax, here's how it looks. On the UI side, Flutter is known for its highly customizability and for its fast rendering. This is possible due to the fact that Flutter doesn't rely on native components, but it has its own rendering engine called Skia. This means that components are rendered on a canvas and they are not translated into native iOS and native Android components like on React Native. The fun and tricky part about this is that you can create a UI that looks nothing like the operating system you're building for. For example, you can even show the native iOS alert on Android, which is mind-blowing. And the good part about this is that Flutter has very fast rendering, and this ensures consistent performance across all platforms. As for the tools, you can use either Android Studio or Visual Studio Code. Both offer excellent support for Flutter, while the Flutter SDK has a lot of pre-built widgets that you can use. Widgets are the UI components. And you also have tools like the Flutter Inspector and Dart Dev tools for debugging and profiling. Another thing that I want to mention here is its excellent documentation, and probably that's due to the fact that Google continuously supports it and improves on it. So in my experience, learning and using Flutter, it was quite enjoyable. This sounds nice. Maybe I should switch to Flutter. Wait, there's one more we need to cover, which is Kotlin Multiplatform. Developed by JetBrains, just like the Kotlin language itself, it was launched in 2020, and it's another framework that allows you to reuse code between iOS, Android, and even other platforms. What's different compared to React Native and Flutter is that with Kotlin Multiplatform, you're encouraged to reuse the business logic side of the code. So things like data models, logic for your app, offline storage, the networking side. So all of these you can reuse across different platforms, and then you build the UI separately for iOS and Android, in our case on mobile. And this provides a good balance of code reusability and that native experience for the user. This shared code is written in Kotlin, which we already covered when we discussed about Android a bit earlier. And this makes it quite a good option for native Android developers who want to try something on the cross-platform side. And even for native iOS developers, because Swift is quite similar to Kotlin. Now, on the UI side, you typically use the native frameworks like SwiftUI for iOS and Jetpack Compose for Android to build the UI separately, which offers a native feel on both of these operating systems. And that's the good thing, but of course the bad thing is that you have to write the UI code twice. Not 4 times, twice. As for tools, you will use Android Studio and the Gradle plugin, just like we discussed earlier on Android. And for the iOS UI side, you can open that project in Xcode and build it like that. Also, you can add different dependencies on iOS and Android. You don't have to add everything in the shared module if you can't or don't want to do that. So yeah, Kotlin multi-platform is kind of somewhere in the middle between React Native and Flutter, which offer the greatest degree of reusability, and native iOS and Android, where you have to create separate code bases for each platform. Alright, we covered a lot of technologies today. Oh yes, we did. Are these all at least? Well, no. There are a few more, but these 5 are the most promising that you can use today and in the near future. And by that, I mean in more demand on the job market, suitable for the majority of apps, with the biggest communities, and offering a good balance between performance, speed of development, and future support. I can make a separate video about .NET MAUI, Compose multi-platform, or Ionic, so leave a comment below if that's something you'd be interested in. As a sneak peek to what's next, we will explore what types of apps are suitable for each of the technologies we covered today, and also what's the best fit for each developer's preference, experience, and the job market. For now, if you found this entire summary helpful, I'd appreciate a like, and also subscribe below for more app development insights in future videos. Until then, I still have something for you. If you want to see a more in-depth comparison between native and cross-platform and a technical deep dive.
All right. I think this is okay. This is the end of today's lecture, but I wanted to sketch your UIs, okay, as somewhere it is shown. Let's see if it is. Okay, this type of things. Okay, this is your main view. We call that view, and there may be some of the buttons, maybe 2 buttons like this. Then from clicking this button, it goes to another view, and another, and another. Some of this maybe come back. So that type of the flow of views needs to be sketched out like this, and this is about your semester project, and this is an intermediate. This is a homework assignments, the next homework assignments, but that is about your semester project. The one that I ask you to submit is this kind of sketch. All right. So that is the next homework assignments.
So in the next assignment, we will have to create the diagram like this?
Correct, yeah.
Got it.
Yeah. Inside here a little bit more. For example, hey, this is login name and password, and there's a button that goes to somewhere like that.
Got it.
Okay? Any questions?